In class, we discussed why these two triangles are similar, and now I'm asking you to calculate the ratio of the corresponding sides. So for example, AC to DF, those are corresponding to each other. AC is 6, and DF is 9. By the way, this could also be written as 6 colon 9, and this reduces to 2 over 3, okay? And this would reduce to 2 over 3 as well. The next pair of corresponding sides would be BC and EF. So I will do BC over EF, and that equals 8 over 12, which also reduces to 2 over 3. I would like you to pause the movie and do number 3 by yourself, the last pair of corresponding sides. So the last pair of corresponding sides would be AB to DE, which is 10 over 15, which also reduces to 2/3. Now, I would also like in number 4 to take the ratio of the perimeter of triangle ABC to the perimeter of triangle DEF. So the perimeter of triangle ABC would be 6 plus 8, which is 14 plus 10, which is 24. And I'll pause to let you find the perimeter of DEF. You should have gotten 36. And now 24 over 36 also reduces to 2 over 3. So as we've seen in class, the ratio of the perimeters is identical to the ratio of any of the corresponding sides. Onward to area. Area of a triangle is 1/2 times the base times the height. So for example, I'm asking you to calculate number 5, the area of triangle ABC, which would be 1/2 times the base, which is 8, times the height, which is 6. And 1/2 times 8 is 4. 4 times 6 is 24. I would like you to pause the movie and calculate the area of triangle DEF. So for triangle DEF, we have 1/2, for the area of it anyway, times 12, which is the base, times the height, which is 9. And 1/2 times 12 is 6. Times 9, you should have gotten 54. And now in question 7, I'm asking you to take the ratio of the area of triangle ABC to the area of triangle DEF. So the area of triangle ABC would be 24, divided by the area of triangle DEF, which is 54. I would like you to pause the movie and reduce that ratio or reduce that fraction to lowest terms. So 24 over 54, if you reduce, the greatest common factor is 6. And 24 divided by 6 is 4. And 54 divided by 6 is 9. So this is the ratio of the areas. Notice it's not 2 over 3, just like the ratio of the sides and the perimeters were. But I want you to take a moment now, pause the movie, and look at the ratio of the perimeters and look at the ratio of the areas and see if you can come up with a relationship. If you're not sure what the relationship is, we're going to cover it later on this lesson, but I want to kind of plant the seeds for you to come up with a relationship of 2 over 3 to 4 over 9. How do you get there? All right, next up, ratio of the corresponding angles. Well, if I take a protractor, for example, and I come over here and I measure angle B, I get about 39 degrees. And if you notice, that's the same as angle E, which is not surprising because the triangles are similar. So the measure of angle B is 39. The measure of angle E is 39. And that ratio simplifies to 1, or 1 over 1. So I would like you right now to pause the movie and calculate the ratio in number 9 and the ratio in number 10. In number 9, there's two ways to think about it. It looks as though angles C and F are right angles. So I can say this is 90 divided by 90, which is still 1 over 1. Or you can just say angle C and angle F are identical. They're congruent because the triangles are similar, and so therefore the ratio is 1 to 1. So the same thing in number 10. A and D are corresponding, so the ratio would be 1 to 1. So there are some conclusions we need to draw. So it says in similar first one says in similar triangles, the ratio of the blank is equal to the ratio of the blank. So as you notice, all of the corresponding sides had the same ratio, and so did the ratio of the perimeters. It was the exact same thing as the ratio of the sides. So in our blank, we're going to put the ratio of the perimeters, which if you're having a hard time remembering, that was, in our example, it was 2 over 3, is equal to the ratio of the corresponding sides. Which was also 2 over 3. Now for the harder one. If you remember, the ratio of the areas was 4 to 9, and the ratio of the corresponding sides was 2 to 3. So the question is, how do you go from sides to area in terms of ratio? And if you notice, if I take 2 and multiply it by itself, I get 4. If I take 3 and multiply it by itself, I get 9. And what that is when you multiply a number by itself is you're squaring it. So we say in similar triangles, the ratio of the areas is the square of the ratio of the corresponding sides. And now question 3 is asking us to go backwards. It says in similar triangles, the ratio of the corresponding sides is the blank blank of the ratio of the areas. So now we want to start with the area ratio. Good morning. And go to the sides ratio. So to go from sides to areas, we square, and the opposite of squaring is to take the square root. So if we take the square root of 4, we get 2. We take the square root of 9, we get 3. So the ratio of the corresponding sides is the square root of the ratio of the areas. And number 4, in similar triangles, the ratio of the corresponding angles was always 1 to 1. Doesn't matter what angles we're talking about, doesn't even matter what triangles we're talking about, as long as they're similar, the ratio is always 1 to 1 or 1 to 1.